let's start with the floor design. So we'll check 5 layers, 180 millimeter CLT made from CLT. We will also use Eurocode 5 plus National Annex, and we'll spend a few minutes on consideration of vibration analysis to see how different analysis impacts our design and what are the options in our tool. So let's jump back to the app. Firstly, we'd like to mention that we have recently a big UI update together with our European release. So now you can even more easily access all the calculation, especially for the member design. So we can start with a new project, or we can also go with the existing one. We'll take you through that in the next calculations. For this, we can set a scope. So for enterprise users, you can switch between the personal one or the company level. So I'll also add this to the company, so the teammates can check this as well. I'll go with a CLT toolbox webinar. So like this, and I'll type in CLT floor, and I'll take slab 101, and I'll go to the calculation. So in seconds, we'll be redirected to the main calculator, and we can start with design. So at the beginning, we can either go with manual layup, or we can select one of the available suppliers we have here. So we can go with CLT as described, with a note that manual layups are only available for pro users. So we can select CLT, and we can go with 180 as we listed at the beginning. For the design, we have default Eurocode 5, but we'll select required National Annex, and we're going to pick up the Netherlands as we have in our project. Continuing with the loads, we have option for adding and selecting different load types here. So because we're calculating the typical floor slab, we only have dead and live in this case. We have default load combination, a loading code, a consequence request. So we'll go with the medium one, as this is something that is related to reliability of the buildings. Now, UDL will also remain here for imposed load to category. As we mentioned, we'll keep up with the category B for office areas. The design equations are here for modification according to National Annex. In this case, a default and only available is using both one. Service class, we can keep to 1. Self-weight will be considered. We'll add topping, as we have in this case, and I'll just add 1.25 as we have 50 millimeter screed. Additional loads will set to 1, and we'll have 3 kilonewtons for lie load. Going further, we have the analysis data. So firstly, we will select the condition type. So in this case, we have already a 2-span equal. I just typed in 6 meters, and we'll configure the other inputs here as well. So we have option for considering the cluster error or stiffness in other direction. This is mainly considering the supplier production technology and yet lamellas. So in this case, we'll keep to no, but just to know that beside every input, you have this green button where you can find out more information about each specific inputs and educational content. The same applies for the analytical method. So how stiffness is being calculated. We have different methods incorporated within the app. So you can switch between extended gamma, or shell energy. But again, for guidance and how you can continue with this, or also where you can find more information, you can find in the educational dropdown, as well as information how the calculation is performed in the background and limitation for the selected method. So we can continue with extended gamma. Going further, we have option for the design code, the deflection data. So we'll keep this as default, and we'll come to vibration part. So as we mentioned, this is something that can be very important in especially in the early stages of design, is especially because the CLT and vibration are not included in the current Eurocode. So we implemented different methods where you can take in some of these for addressing your specific situation. So we can start with HAM method. This is a method developed at Technical University of Munich, and based on it, the Austrian National Annex included verification for CLT vibration. So we can type in 8 meters for the secondary width. Damping will remain 0.03 as recommended with floors with screed. We'll keep the floor with higher demand, and we'll add a screed stiffness consideration because we want to add the in-plane stiffness in this case. will have 50 millimeters and will just slightly increase the stiffness of the screed. So based on it, we can see immediately that this verification is not satisfied. And also, we also have to note that with each of these methods, we have some limitation. So in this case, a ham method is only applicable for the stiff support. So in case we have supported with GLT beams, we know immediately that the results will not be that precise. So we can switch to revised Eurocode. Know that FP innovation is also applicable, but it's more likely that this will be useful for the US region. So if we go to the revised Eurocode, we can see that some inputs are new here, especially with introduction of full performance level. So again, educational content can be very helpful here. There is introduction where you can start with what performance level is suitable for your starting point and your specific construction you're taking. So we can go with second performance level. We'll keep the secondary width as it is. Walking frequency, we can start with 1.5 hertz. The floating screed, again, will have the same values as we have on the previous method, and we'll just here in the additional input where we have support condition, we can change from rigid to flexible. So we can add the contribution of the beams and have more precise values considering our situation. What we also have with these inputs, we have properties of the beam, so section depth, width, module elasticity, and self-weight. We'll keep these values for now, as we don't know what are the exact dimensions of beam. We'll calculate it later, so we can come back later and check up the results again. So for the output summary, we can see that in this case we have passed deflection, vibration, ambient shear, and bending, and we can go into details with these tabs on the right. So if we want to check some intermediate results, you want to check references, or even cross-check with other software, you can trace down the calculations from the start to the end. So you have information also about the annexes, loading code, both for ultimate and serviceability limit state load, analysis part. So for each combination, you can see what are the shear forces and bending moments, deflection, vibration. So in detail, in this case, you can check what are the all the criteria and the necessary requirements. So for the frequencies, velocity, and acceleration as well. And the last part will cover design code. So a string check for bending design, shear design, and rolling shear. And you can see also the checks for governing load combination as well as utilization number. We'll save this and we'll go with our design.